Hi, it's me again. Um, so this is binomial distributions. Um, Again, please use the PowerPoint that I attached to fill out these parts, right? But I'll go through this one. Now, binomial distributions are useful if you have so many trials, because back when we were looking at PDFs, probability distribution functions, we only had a few trials, right? We only had like 5 different values of x and y. That kind of represented that we had 5 trials. But imagine if you have to toss a coin 6,000 times, right? If someone asks you to what the probability of getting ahead is on the 5,040th time, right? What would you tell them? What's the probability of getting ahead? Or what is the probability of, in 365 days that it will rain on the 248th day? What is that probability? So, or what is the probability that it rains between 248 to 322 days, right? Just random things like this. If you have so many trials of an experiment, then it becomes difficult or impossible to have a probability distribution function for those probabilities. What can be useful is if you have a binomial distribution, and the binomial distribution is helpful for large number of trials. So the characteristics of a binomial experiment: you have a fixed number of trials, right? Fixed number of trials, and there are only two possible outcomes, and those outcomes are called success or a failure. So what I'm trying to say here is, imagine you are tossing a coin 8,000 times, right? So you have a fixed number of trials, which is 8,000 times. There are only two possible outcomes, which is, you can, let's say that the event you're interested in is getting ahead. If the coin is not biased, then there are two possible outcomes. You could get the head, which is a success, or you may not get the head, which is a failure. So that's why the two possible outcomes are called success and failure, right? These are some of the characteristics of a binomial experiment. If this doesn't make sense, think of another scenario where you are looking at the random variable of Shannon going to school out of 40 days, right? 40 days in a year. If I pick a random sample, 40 days in a year, and I'm trying to represent the probability distribution function that Shannon is going to school, a success is Shannon going to school. A failure is Shannon does not go to school. She could go somewhere else, she could stay at home, but the success is going to school, the failure is not going to school. So that's a binomial distribution. If you have two fixed outcomes, which could be a success and a failure, binomial distribution. The letter P is used to denote a success. It gives you the probability of a success. And the letter Q gives you the probability of a failure. I'm intentionally writing terribly so that you have to use the PowerPoint to check these things. And another interesting factor about a binomial distribution is that P plus Q is always equal to 1. The n trials are independent. This is important. The n trials are independent for a binomial distribution. So the probability that the 40th trial happens is not affected by the probability that the 36th trial happens. So that the trials are independent and are repeated using identical conditions. Because the trials are independent, the outcome of one trial does not help in predicting the outcome of another trial. For a binomial distribution, the mean is simply the number of trials times the probability of a success. The variance is simply the number of trials times the probability of a success times the probability of a failure. And the standard deviation is the square root of variance, which would be the square root of NPQ. So let's look at some examples. The Health State Board is concerned about the amount of fruit available in school lunches. 48% of schools in the state offer fruit in their lunches every day. This implies that 52% do not. What would a success be in this case? Since the health board is concerned about the amount of fruit, this is what they are concerned about. So the success would be finding fruit in a school lunch. So a success in this case is a school that has fruit in its school lunch, right? And if there was another question, what's the probability of a success? It would be 0.52. No, sorry, 0.48, because it's 48. Probability of a failure is 0.52. Another question in here, you play a game, you can only win or lose. The probability that you win is 0.55, right? So that means the probability of success is 0.55. The probability that you lose is 0.45, so failure is 0.45. Each game you play is independent, okay, so this confirms that it's a binomial distribution. If you play this game 20 times, the number of trials is 20. Write a function that describes the probability that you win 15 of the 20 times. So this is simply probability that you win 15 of the 20 times. This is how you write a probability in a binomial distribution. As far as how to calculate this is concerned, I'm going to show you that in a little bit. But this question is simply asking you to write the function that describes that probability, and that is simply p of x is equal to 15. Try 2. Train is teaching a dolphin to do tricks. The probability that the dolphin successfully performs the trick is 35, then the probability that it does not is 65 out of 20 attempts. So this is success, this is failure, this is number of trials. You want to find p of x is equal to 12, so this is simply p of x equals 12, and you can fill in these others. Or you can fill in these others, so success, failure, number of trials, and yeah. Let's see if there's something here that you might need help on. Find the probability that at most 12 of them. Okay. Notation for binomial distribution. So you can do this one and this one. Let's look at the notation. The notation for a binomial distribution, or the probability distribution function for a binomial distribution, is simply stated like this: that x is a binomial distribution with n trials and p as the probability of successes. This simply tells us everything we need to know about a binomial distribution, because we're interested in 1, the number of trials, and 2, the probability of a success. Since we know that 1 is equal to p plus q, if we know p, we can always find q, so we don't need to state q in our notation for a binomial probability distribution function. Okay, let's look at the example. 41% of adult workers have a high school diploma, so this is going to be your p, but do not pursue further education. If 20 adults are randomly selected, this is going to be a number of trials. Write a binomial PDF for this function. X is a binomial PDF in which you have 20 trials and the probability of success is 0.41. Find the probability that at most 12 of them have a high school diploma but do not pursue any further education. So probability that at most means less or equal to 12. How do I do this on my calculator? So on your calculator, press, and I'll show you in the next video, but I hope you can be able to follow this. Press second function, right? Look for a button that says bars. That button above it, it says distribution in blue and small letters. So when you push second function, push that button, scroll down until you find binomial PDF, right? Binomial PDF. If you push that, hit enter, it brings you to a screen that says binomial PDF, open brackets, then you put in the number of trials, which is 20, put in the probability of a success, 0.41, and then put in this number 12. The number 12, it will give you the answer to that probability. If you have a question about this, please refer to the next video on the next classroom post. How many adult workers do you expect to have a high school diploma? Expected value of a binomial distribution is the mean, which is n times p, which is just 20 times the probability of success, which is 0.41. So that gives you the expected value. Right, try to use your calculator. If it's not helping, refer to the next video if you haven't yet got it. And yeah, you can do this one on your own. Yeah, the only thing about this one that might be difficult, because you can do this using a calculator, wait, oh, so I confused you here. When it said at most on this part, I'm really sorry. When it says at most, and I'm going to explain, I was hoping to explain this in the next video. Actually, yeah, let me just explain it in the next video. See you in the next video.